All right, how's everybody doing? Doing well? Okay, this is the last full week of school. Next Friday will be the last time I see a lot of you. But if you're a senior, you're actually going to be taking your final sooner. It's going to be next Monday and Tuesday. So I just went down and talked to the office, one of the administrators, just to confirm. But on Monday, coming up a week from today, you'll take your odd numbered period finals. And then on Tuesday, you'll go ahead and take the even number period finals. So like on Monday, you'll take 1, 3, 5, 7. So really Tuesday is going to be the last time I see you guys, and Monday will be when the seniors final is, and then everybody else will take it next Friday because that's 5 through 8, the half day. Okay, so that's coming up. As far as the final goes, I'm getting it ready. Yes, sir. What's that? Yeah, so Monday and Tuesday are the seniors' last days. So usually on Wednesday and Thursday, they have meetings like at the gym to kind of let you know what's going to be happening for graduation, last-minute details, anything that's coming up. Then on Friday, next Friday, the 24th, there should be probably about in the late morning, early afternoon rehearsal. You guys will all meet at the, I still call it the Spirit Arena. What is it, United?
I thought it was Spirit Arena.
Yeah, I still call it Spirit Arena. Yeah. So at the Spirit Arena, you'll run through rehearsal a couple of times, and then that night you'll walk across the stage. Everything will be good.
I thought we were going to main event.
Sir?
You said we're going to main event.
Yeah, the graduation's at main event. They're going to walk the bone.
Are they? Hey. Sounds like a plan. I mean, get your degree and, play a little bowl or laser tag or what else they got there? They have miniature golf there?
Yeah, putt-putt.
That putt-putt? Okay. It's been a long time since I've been there.
They got new arcade machines.
Do they?
Yeah, they also got, what's that game? Like, shuffleboard, but like on a
Oh.
table. But like, that's
Oh, I know what you're talking about. Yeah,
Yeah,
okay.
like-
That's cool.
bar.
All right. But let's see. As far as the final goes, what I'm going to do, I put together a review and the final. It's only 10 questions. It's multiple choice. But what I'm doing this time, the review and the final are the same. Same questions, same answers. So if you feel, well, you guys can. I won't go over it with you since I'm doing that. But if you feel good about the review, that final should take you seconds. Okay, I'm going to try and get that to you in the next couple of days because I know the seniors are graduating early. Well, not graduating early, but they are leaving school early. They won't be here starting next Wednesday in class. I am going to miss you guys, yeah. What? Just like I've said before, I mean, this isn't English, but it was always lit. I hope that by the time you guys leave, you feel that you actually learned something. You thought it was worth your time. I'm hopeful because you guys have done a good job this year. I appreciate it.
Can't
Okay.
you just be like, who's the coolest teacher? Who's the least?
You want the best? Come to the West.
Hey.
That's actually good. You should write that down.
There you go. There you go. So a few other things, Mr. West. Yep. The only other big item is on Friday. You've got your last test of the year. That'll be exam 2. You can always use your notes. It's all multiple choice, but it's going to be over arithmetic and geometric sequences and series. So pretty much that is the last grade. You got this right here. This will be due on Wednesday. We got a couple of days. You'll even have time in class today to work on it. Focus activities are going to be due on Wednesday. I believe now you have 3, 4, and 5. All you need is 6, and you'll get that tomorrow. And I think that's pretty much it. We're in the end now. Bless you. We got less than 2 weeks. Hey, Nathan. I like rock and roll. Like Aerosmith is my favorite band. I'm sorry? Am I going to what? NWA? I guess I'm not familiar with that one. Straight Outta Compton, that sounds familiar. Easy. No, the name is familiar. I've probably heard the music, but it's been so long.
That's not a good idea right now.
No, not right now.
It's okay. Game. Let's not focus on that.
All right. Well, there is only one little thing left I have to go ahead and show you. And it's finding a coefficient, say, of a particular term. We've been talking about the binomial theorem and using Pascal's triangle. We've been talking about the patterns and all that good stuff that you're going to see. So we've been getting away from it. But if you'll go ahead and take a look at this right here, I believe it is like maybe the second or third page of the notes. Oh, I got something in my eye. Oh. And if you've misplaced that copy, there should be extra copies over there in the files by Christian. Okay, so this is what we call a combination. Okay, that's what the C stands for. You have two subscripts. The first one is N, and the second one is R. Okay, and you can actually use this to go ahead and expand the binomial as well, but we're using Pascal's triangle. But I do want to go ahead and show you, if you're looking for a particular term, okay, the power on the second term, that's R. The power on the second term is R. Now, N is the power that you're originally placing on the binomial, okay? So here's the formula. You take N factorial divided by N minus R factorial times R factorial. Okay, so what this means is N factorial is I'm going to start with that value and I'm going to multiply by the whole number of values as they decrease all the way to 1. Okay, so let me give you an example. If I were to take this, 5 factorial, if I saw that, what this tells me to do, that exclamation point in math, it means to start with 5, but multiply by all the numbers less than that. So 5 times 4 times 3 times 2 times 1. Okay. Now, you don't have to worry about 0. But there is a definition, 0 factorial equals 1. Okay. All right. So, and also, you could go ahead and multiply this. Like, for example, 5 times 4 is 20. 20 times 3 is 60. Times 2 is 120. Okay. Now, you could also do this. If you go to your calculator, all right. Let's say I want to go ahead and put in 5, and then I want the exclamation point. I believe it was right here. Nope, it was not. So where was that? I always do it by hand, so I have to find it. Let's see. It wasn't there. Do I see it somewhere on my screen? Nope. It's next to the G. There it is. Yes, right there. Okay. I knew it was somewhere over there. Hey, Antonio. Yeah. So right down here, right next to G, you have the button that has the question mark, the exclamation point. So I got that in. Let me escape out of it. If I go ahead and push enter, see, it'll give me the 120. Okay. It's just been so long since I looked at factorial, I just forgot where it was. Okay. All right. So when you're finding a combination here, you just want to use this formula. Okay, the first subscript is in the numerator. Then you have N minus R factorial times R factorial. So you just simplify it, and that'll go ahead and give you the coefficient of the term you're looking for. Okay, so let's go for an example. Okay, now I'm not going to go ahead and give you ones like this where it asks you to find like the 5th term, 6th term. I'm going to give you problems like this where it shows you the combination that we want. We want the x to the 7th y squared term in this expansion. Okay. Now, what we're going to use is that little formula that we were just looking at. The combination of n and r, it's equal to n factorial over n minus r factorial times r factorial. Okay. So remember, these terms here, this is A, this is going to be B. Okay. So we're still going to go ahead and plug those in just like normal, but when you're asked to find this, R is always going to be the second term's power. Okay? R is always going to be the second term's power. So here it's y squared, so I know R has to equal 2. Okay? Can anybody tell me, what do you think N is? Okay? It's got to be the original power we're placing on the binomial. Okay? So it's got to be 9. N equals 9. Okay, so I'm going to have the combination of 9 and 2. Is everybody okay where I found those values?
Yeah.
Okay. R is always the second term's power, and then N is the original. So if it doesn't give you the binomial expansion, 7 plus 2, you can still find that out. You can just add up the powers. Okay, well, let's apply the formula. I'm going to have 9 factorial over 9 minus 2 factorial 2 factorial. Okay. All I'm doing is plugging into the formula. Well, what's 9 minus 2? 7. So this is 9 over 7, 2 factorial. Okay. Now you could just go ahead and plug that into the calculator. Does anybody want me to show you a method by hand? Sure. Okay. Now 9 would actually have me say 9 times 8 times 7 times 6 times 5 all the way down to 1, right? And then I do the same thing for 7, and then I'd have 2 times 1. You could multiply that out and divide, get your big numbers, but you can also do this. I can go ahead and say 9 times 8, but I'm going to stop at 7. Why do you think I stopped there? Because what do I have in the denominator? Because 7 would be 7 times 6 times 5 times 4, so it's like I could simplify this by canceling out all of those values. So really all I have is 9 times 8 divided by 2. Okay, and that's what I like to do, especially if I'm working it by hand. Well, what's 9 times 8? 72. 2 times 1 is 2. And what's 72 divided by 2? 36. Okay. Now remember, that's not the end of the problem, though. That just helps you figure out what to start with. So I'm going to go ahead and put the 36 right here. And then right next to it in parentheses, I'm going to put my 2 terms, just like when we expanded them last week. So the first term is 4x, and the second term is negative 3y, right? Okay. What powers do you think are going to go on those? There you go. I want the x to the 7th and the y squared term. So I'm going to raise 4x to the 7th and negative 3y to the squared. And now I want to go ahead and simplify this. Okay. So first off, I need 4 to the power of 7. So I'm going to come on over here to my calculator. 4 to the power of 7. So that's going to give me 16,384. Okay. So that's a big number. So this one right here was 16,384 x to the 7th. We still have the 36 out in front times, well, what am I going to get if I square a negative 3? Positive 9, and then we have the y squared. Okay, so what do you think I got to do to get my answer? All I got to do is multiply those numbers. So 36 times 16,384 times 9. So it's going to be, pretty large. So I'm going to multiply that by 9 times 36. There we go. So the coefficient should be 5,308,416. 5,308,416. And then, of course, we have x to the 7th, y squared. There you go. Okay. So sometimes you might be given a question where you don't expand the entire binomial, but you can just find one specific term. Okay. All right, well, let's try another one of those. Okay, so if you go over here, so you'll notice I'm changing this. Your original note said find the 3rd term, find the 4th term. I'm just going to have you find a particular power combination. So for example, 9, I want to find the a squared, b squared term of x minus 3 to the 4th. And then example 10, I want to find the a squared, b cubed term of 3x minus 2 to the 5th. In fact, if you look on your assignment, I've already changed your notes on that particular problems to these versions. Okay. So let's do number 9. What is R? R is 2. Remember, R is always the second power, the power on the second term. So what's N? N is 4. N is the original power that we're placing on the binomial. Okay. So what I want to find, I need to figure out the combination of 4 and 2. Okay. Well, let's see here. That means I need to take n factorial, so this is 4 factorial, over, what's 4 minus 2? 2 times r. Okay. Or does anybody actually want me to go ahead and show the substitution where I take n minus r? Would anybody like me to put that in? Or even write the original formula? Would anybody like me to do that? Okay. Now, like I said, I didn't show you this on the previous one, but I could just go ahead and type in what I see right there. Okay. Oh, I got a text message. So sorry. So I'm going to hit 4 exclamation point. Okay. And then divide that by 2 exclamation point times 2 exclamation point. Okay. So exactly what I have on my paper. So you don't even have to do it by hand if you're not wanting to do so. So when I push enter, I'm getting what? 6. Okay. But does that mean that's the coefficient of the term I want? Okay. So I'm going to go ahead and put the 6 here. And right next to it in parentheses, I'm going to put the 2 terms for my binomial. So the first term is just x. What's the second term? -3. And now remember, what power combination did I want? I wanted the first term squared and the second term squared. So squared, squared. Remember, just like on the previous one, I put the 7 and the 2. I put them in order. Okay. So this one's going to be a lot nicer number. We've got 6 times x squared times -3 squared? 9. So 6 times x squared times 9. Oh, a little high.
So,
54x squared. There you go. That's it. Okay. Questions? Okay. All right, well, let's try this one. And this will be our last example. And then for the remainder of the period, I'm just going to go ahead and turn you loose, let you work on the assignment. It's due on Wednesday. Okay. So let's see here. A squared b cubed. So what's the value of r? R is 3. Remember, it's always the second term's power. And n equals 5. Yes. Is everybody okay where I'm getting those numbers? Okay. So what we want is the combination of 5 and 3. Does anybody want me to write out the original formula? Okay. I'll tell you what, on this one, I will go ahead and show the substitution. So we have n factorial, so that's 5 factorial, over n minus r factorial. So I'm going to say 5 minus 3 factorial times r factorial. There you go. And then, of course, we know 5 minus 3 is 2. There you go. There you go. 5, that is correct. 5 times 3. All right. All right. Now, would you like me to work this by hand or plug it in the calculator? Let's do it by hand. So remember, I've got these 2 denominators down here, 2 and 3. When I start to write out the 5 factorial, I can choose to stop at either one I want. I would probably stop at 3, stop with the larger number. So 5 times 4 times 3 over 2 factorial, 3 factorial. So those cancel. So it looks like this would be what?
20 over 2 factorial.
Where are you getting 20 from, sir?
5 times 4 divided by the 2. What? Oh, that's fine. That's fine. So it should be 10. Should be 10. Okay. Now what? Now what do we do? Is the answer just 10? Okay. There we go. So now I'm going to put the 2 terms right next to it. In fact, what's the first term? 3x. Then we got a -2. And remember, I want squared and cubed, so I'm going to square that one. I'm going to cube that one. Okay. So let's see here. What is 3x if I were to square it? So this is 10 times 9x squared times... Now, because it's an odd power, -2 cubed would be what? It would be -8. -2 times -2 times -2. Okay. So now, what is 10 times 9 times -8? What's that? Oh, you're forgetting one detail. Negative. So -720 x squared. There we go. That is all there is to it. And that is our binomial theorem. Questions? You will have to ask Mr. Owl.
Why don't you find out?
Now once you find out.
They cut your time. They really do cut your time.
Do that for your final?
Cookie probably never make it feel like it's
1, 2, 3. And then I do something, you're like, I lost count. 1, 2, 3. Okay, so let's do this. Is there a problem on the assignment you would like to work together? Would you like to expand one just to remember? Because it's been several days since we talked about it. Which one would you like? Like one that's just negative? 4? You want me to expand 4? Okay, let's do 4. Okay, so let me ask you a question. How many terms will I have in my answer? 5. Remember, the number of terms is always one more than the power you have. So what row on Pascal's triangle am I going to look at? 4th row. The thing about Pascal's triangle is, though, it always starts at 0. So 1, 2, 3, 4, I want the coefficients 1, 4, 6, 4, 1. Okay? And that makes sense. There's 5 terms in that particular row. 1, 4, 6, 4, 1. Okay. So 1, 4, 6, 4, 1. We are doing number 4. Move these a little bit. Now, why am I leaving so much space between them? There you go, because I got to go back and plug in those variables. In fact, my 2 terms, I have in and what? And -4. So right next to each one of these, I'm going to put in and then -4. And then in, -4. In, -4. In, -4. And one last time, in, -4. Now, what's the pattern on these? Like, what is the first term's power do? There you go. What am I going to start in with? Okay, so it's n to the 4th, n cubed, n squared, n to the 1st, and n to the 0. So the first term's power will get smaller. The second term's power will get larger. So we have 0, 1, 2, 3, 4. Okay. And you'll notice on each one, the sum of the powers will always be the original power. 4 plus 0, 3 plus 1, 2 plus 2, they all give me the 4. So let's try the first one. So we have 1 times n to the 4th. What would -4 to the 0 be? 1. Okay. So that would be n to the 4th. That's the first term in my answer. Okay. And now let's do the next one. So I have a 4. I've got the n cubed times -4 to the 1st. So that'd be -4. So this next term would be -16 n cubed. So how do we know that these signs were going to alternate? Like the next one should be positive.
Because of the powers.
There we go. When you start with the second term being negative, you'll always see that alternating. It'll always go plus, minus, plus, minus, plus, minus. But if it's a positive second term, it'll just be plus all the way across. Let's see, for the next one, we have 6 times n squared, -4 squared. Oh, positive or negative? Positive 16. And then I need 16 times 6. 96. So positive 96 n squared. Is everybody okay with where I'm getting these values? Okay. Anybody confused? All right. So the next one here. Looks like I have 4 times n. What's a -4 cubed? So -4 times -4 times -4.
Hold up.
You okay?
A little high.
I don't know. Is it between each one?
So 4 times 4 is 16 times 4. Oh, you're talking about the final answer. Okay, okay. So I was thinking -64. There you go. Okay. Sorry, I was still on the -4 cubed times 4. There you go. So -256. So we were both correct. We were just talking about different things. There you go. Okay. And our last one here. So 1, n to the 0 is 1. -4 to the 4th this time will be positive 256. So it's just 256. There you go. And that's it. Yay. What's up? Well, because it's an even power, we should be ending up with a positive.
I put a negative 4 instead of 4.
Oh, in the calculator? Now, did you use parentheses? Because the calculator is programmed to use order of operations, just like you were taught. If I go ahead and plug in -4 to the fourth, see, it'll take care of the exponent, and then it sees that as multiplying by -1. So if you go ahead and put it in parentheses, -4 to the power of 4, see, it's telling you to take that negative when you apply the power. So there you go. Okay. Did we want to go ahead and do one of the problems where it was asking for a term? Okay. And you'll notice if you take a look. Okay. See, on 11 and 12, I went ahead and changed that. So 11 is a to the 6th b squared, a to the 6th b cubed, and I don't think I have it on here. Oh, I do. A cubed b to the 4th and a to the 4th b squared. That is on your paper, correct? Okay. Which of those would you like to work?
Can we just cry? I mean, like,
Why?
Why are the bottom points 9, 10, 11, 12?
Now, I will go ahead and tell you, I'll completely admit when I make a mistake. I got this from a different resource. I did not do that. So I will go ahead and tell you, that's why it's 15, 16, 17, 18. Okay. That was not my mistake. Yes. Okay. So is there a 11, 12, 13, or 14 we'd like to do? That's a cubed b to the 4th. 13 is a cubed b to the 4th. Is that the one we want to work? No?
Yeah.
Yes? Okay. So, Antonio, on number 13, what is R?
Wait, hold up.
Is it 3, 4, or 7? It is 4. There we go. Remember, it is always the power on the second term. What's n? 7. So I want to find the combination of 7 and 4. Okay. So just like we were doing a few moments ago, I'm going to take 7 factorial over 7 minus 4, 3 factorial, and then 4 factorial. Okay. So this one, you just want to put in the calculator? Or would you like to work it by hand? Calculator, okay. So let's see here. If I come back over, control divide, I need 7 factorial. And then I need 3 factorial times, that's not plus, okay, times 4 factorial. Okay. So if I plug that in, I'm getting 35. What you guys are getting? Okay. So now that's going to help me get my answer because now I'm going to put the two terms right next to it. So the first term is x, second term is 2, and what powers will I place on them? Cubed and fourth, because that's the term that I'm looking for. The first one's cubed and the second one's to the fourth. So let's see, that is 35. This next one is x cubed, 2 to the fourth, times 16. 2 times 2 times 2 times 2. So all we need is 35 times 16. 560? 560 x cubed. That's it. That's all you got to do. So number 15 through 18, you're just going to go ahead and give me the first two terms, and then go ahead and tell me how many terms would be in the answer. That's it. Did we want to go ahead and do one of those, or just list me the first two terms in the answer? Yeah, which one would you like? 15, okay. So a plus b to the 12th. All right. Well, how many answers total would it have? So it'd have 13 terms. Okay. All right. And now we want the first two. So we're going to have to do this by going to the 12th row. This is the largest one I believe we have on this paper. So we're going to need to figure out what the first two terms are in the 12th row. So let's go to Pascal's triangle. Right over here. Now, so far with what we have, we've gone to the 9th. We still need to go 10, 11, 12, right? Now, here's what's nice about this. Do I need the entire row? I just need the first two. Well, I know the first coefficient's got to be what? It's got to be 1. Okay. So let's see. If I drop this 1 down, then 1 plus 9 would give me 10. You're up. You're up. You add. You add those. And now we'll just go ahead and get a few terms. What's 9 plus 36? Okay. 46?
Wait, what's the
9 plus 36? 45. Okay. See, in order to get the 2 on the next one, I got to get at least the first 3 because I'm adding those, right?
Yeah.
Okay. Well, so that's the 10th row. So that would be 11, and then I need 55. Okay. So that's row 11, and now for row 12, I got 1, 12, and then that would be 66. Okay. So there we go. Those are my coefficients. Is everybody okay with that? Okay. 1 and 12. Okay. So I'm going to come on back over here. Okay. So I'm going to put the 1, I'm going to put the 12, and then right next to them, I'm going to go ahead and put those 2 terms, and we just have A and B. So there's A and B, A and B. Now remember, these are just the first 2. So what would that first power start with? That'd be 12, and B would be 0. Then we move to the second term. A would be 11, and B would be 1. And we would add because we're adding the original terms in the binomial. So that first one would just be a to the 12th plus 12 a to the 11 b. That's it. I'm sorry? That's number 15. The second number 9, yes. Now, of course, your answer would have 11 more terms, but this one just wanted the first 2. And that's it. That's all you got to do. Question. You want to go to the nurse?
I'm sorry. Can I go to the nurse?
You sure? Okay. All right.
Myself would get to go home either way, so.
Okay. Well, all right. Let me go ahead and shut it down.